Okay, good afternoon, students. We will see a few questions from today's exam. It is given that first 26th one. It is given that charge Q1 and Q2 are separated by distance d, sir. Okay, and it is placed in a dielectric constant of k. And now, what will be the equivalent distance between the charges if the same charges are present in the air? Okay, now we will see. First, when they are in the medium, the charges are separated by distance of d, sir. Okay. Now, what is the formula between these forces when they are in the some medium which is having a dielectric constant of k, which is equal to 1 by 4 pi epsilon q1 q2 by d square, sir. But what is the epsilon permittivity of the medium? What is its formula? 1 by 4 pi epsilon value is epsilon naught k, so q1 q2 by d square. Now this is f1, sir. Now they are taken into air. When they are in air, the formula is f2, which is 1 by 4 pi epsilon naught q1 q2 by d square. Now they are asking what is the equivalent distance between these charges when they are taken into air, sir. Here q1 and q2 are there. Now it is in air, so the charge between them changes. Let us imagine that final change is x, like final distance is x. Now they are in air, and the condition is they should have the same force. That means here it is f2, here it is f1. Now f1 f2 should be same. In that case, what should be the final distance they are asking? That means it is x, sir. Now what I am doing is I have to calculate x. So for that f2 is equal to f1. What is f2 f1? 1 by 4 pi epsilon naught k q1 q2 by d square. Here what is f2, sir? 1 by 4 pi epsilon naught q1 q2 by d square. If you cancel the similar quantities on both sides, 1 by 4 pi epsilon naught will go, q1 by q1 q2 by d square also will go. So what is sorry d this is x square. X square will not go, so d square will be there. So on this side it is d square, on this side it is k d square, this side it will be x square. So if you cross multiply, x square is equal to k d square and x is equal to root k d. So which is the option? Right option, d root k. Is that okay, sir? D root k is the option. Next, second one. We have already discussed electric field inside a metallic solid sphere. Metallic solid sphere means it is a conducting sphere, so electric field will be zero inside. So electric field lines exist only outside the sphere, inside it will be zero. So fourth option will be the right one, sir. Okay, now come to 29th one. This is the 26th one, sir. Now we will discuss 29th, which is two equal point charges of each 3 microcoulomb. Okay, two equal charges are there, separated by distance in meters. They are located at position vectors are given, sir. First charge is located at ijk, second charge is located at 2i, 3j, 3k. Okay, then electric force between them is, for example, let us take a coordinate axis as they have given position vectors. First one q1 I am taking, which is at ijk, sir. See, this is here the vector is in 3-dimensional, so you have to imagine the position in 3-dimensional. That is q1, which is r1, sir. The position of the first charge is r1 bar, which is given as ijk. Okay, now position of second charge is 2i, 3j plus 3k. Okay, now second charge somewhere it is there, sir. That is a q2, and that position vector is r2 bar. Now they are asking what is the electric force between them. We already discussed. Anyhow, the final options are in magnitude only. So we need to discuss. We need to have the formula which is in the magnitude itself, which is k q1 q2 by. For example, if you think this is r square, sir. Okay, k value is known. q1 q2 both are same, so q square. R value we don't know, sir. So how do we get R value? Simple. We already discussed this is the third side of a triangle and which is given by subtraction of both vectors. For example, if you think this is r21, position of 2 with respect to 1, that is given by r21 is given by r2 bar minus r1 bar. It is subtraction of vectors. So what is r2 bar? R2 bar is equal to R2 and 2i plus 3j plus 3k minus R1, which is I plus j plus k, sir. So the final answer will be R21 is equal to 2i minus I, 2i minus I, 3j minus j, 2j, 3k minus k plus 2k. Okay. Now what is the magnitude of R here? Whatever the R I have written in this formula, that is R21 bar magnitude only, that is equal to root of 1 square plus 2 square plus 2 square, which is 2 square 2 square 4, 4 plus 4 9, 9 plus 1 root 9, that is equal to 3, sir. Okay, I'll put now substitute all the values which we know, which is k 9 into 10 power 9, q1 3 micro, q2 3 micro. So 3 into 10 power minus 6 whole square by r square, which is r we just now found out 3, r square means 9, 9 gets cancelled, and 3 square 9. So in this numerator we will get 9 into 10 power 9 into 10 power minus 12, 10 power minus 6 whole square means 10 power minus 12. So 9 into 10 power 9 into 10 power minus 12, 10 power 9 minus 2, which is 10 power minus 3. Okay, so 9 into 10 power minus 3 Newton, because everything we have substituted in SI units, we will get force also in Newtons. So which options are 9 into 10 power minus 3 Newtons? Second option. Okay, we'll move on to next question. From here onwards, it is 29th question. Okay, now we will see, first we will complete all the numericals. Now here it is given a infinitely long wire of uniform charge density lambda. So it is infinite wire having a uniform charge density lambda, sir. Given data is lambda first. The net flux through a Gaussian cube of side length, for example, infinite wire is there, sir. Okay. Now there is a Gaussian cube of side length root 3 centimeters. If the wire passes through any two corners of the cube, that means if you take a cube, the wire should pass through this one, the wire should pass through this one. If you think this is A, B, C, D, E, F, G, somewhere here H you will get, sir, which is behind the cube, which is not visible for us. That's why I have shown in dotted. Now they are telling, imagine a line which is passing from A to F. Okay, now what that are maximally displaced from each other. Okay, the given wire should pass through two corners of the cube, which is having maximum distance between them, and that force the net flux value is given, sir, which is net flux value is given, which is x Newton meter square per coulomb. What is the x value they are asking? So how do we proceed? Simple, sir. We have to take what is the flux formula? Flux is equal to q by epsilon naught, but we don't know how much q is trapped inside this cube. You see, obviously in this flux formula, q is the charge enclosed in the Gaussian surface, which is closed. So q will be, so how do we get q? Q is equal to linear charge density into length of the diagonal. Correct? What is lambda? So lambda is a charge per unit length. Per unit length we don't want charge. For total L length we need how much charge is there. That is given by lambda multiplied with L. So flux is equal to Q lambda into length. What is the length? What is the cube length, sir? Cube length will be root 3 a, sir. For example, what is a? A is a surface, a side length of a cube. What is the diagonal length when the surface? What is the diagonal length when the cube side is a? Root 3 a, sir. Okay, now. So what is the lambda? Lambda is given. A is also given, and flux is equal to, you need to substitute the values. Lambda is 2 nanocoulomb, that is 10 power minus 9 coulomb, into root 3 value into a, which is side length. Side length of a cube is root 3 centimeters. Okay, centimeters should be converted into meters, so multiplied with 10 power minus 2. Denominator. Why denominator? Because flux is equal to charge by epsilon naught. No, sorry, I forgot to write that. Epsilon naught value is sir, you don't have to remember the epsilon naught value, because we know 1 by 4 pi epsilon naught value is 9 into 10 power 9. So 1 by epsilon naught value is 4 pi into 9 into 10 power 9. So we'll substitute that value. So what is 1 by 4 by epsilon naught? It is 1 by epsilon naught only. So what I'll do is I'll substitute 1 by epsilon naught value as a 4 pi. So already root 3 into root 3, 3. 2 is there, 3 is there. Now multiplication 2 into 3 into 10 power minus 9 and 10 power minus 2. Now the 1 by epsilon naught value, which is 4 pi 10 power 9 into 10 power 9. Okay, now let us solve this. It will become 2 into 3 6, and 6 into 4 into 9, it is there. Okay, and 1 pi is also there. Now multiply 10 power 9, 10 power minus 9 gets cancelled with 1, and 10 power minus 2, into 10 power minus 2 is there. Now they are asking x value, sir. So simply it will be 6 4s 24, 24 into 9. This is a 3.14 into 10 power minus 2. Oh, sorry. Options are given in terms of a pi, so no need to convert this into pi. You can leave it at pi. So 24 into 9, how much? 24 into 10 is 240, sir. So 240 minus 24, which is 216 into pi. 10 power minus 2 is there, so it will become 20. So 2 decimals will come, decimal points 2. So 2.16 pi is the answer. So fourth option. Is that okay? Let's go to 30 seconds, sir. Let's see the question first. So a small charger particle of mass m and charge q are suspended by insulated wire in front of a very large conducting sheet of uniform surface charge density. See, we already learned if surface is there, like a large conducting sheet, what is a large conducting sheet electric field? Field created by a large conducting sheet is sigma by epsilon naught. If it is a non-conducting, sigma by 2 epsilon naught, but because it is a conducting, so it is sigma by epsilon naught. And that will create an electric field on this charge in this direction. I am erasing this quantity, sir, here. Okay. So electric field will be in this direction, and weight of this ball mg will be acting downward. Now they are asking, what is the angle made by thread with the vertical in equilibrium? For example, because of these two forces, net force will be somewhere in between E and mg. Okay, it will be exactly 45 degrees. That means this wire will come under this ball, because of its weight and electric field, the force created by electric field, it will get into a direction where net force will be there, sir. Okay, Now they are asking this, what is this angle? Simple. That means indirectly they are asking this angle. So if you construct one triangle, this is electric field. Sorry, this is electric field. This is mg. This is the hypotenuse resultant force. But as this is a theta, we don't need to calculate resultant. Simply tan theta is equal to electric field by weight, sir. Sorry, electric force by weight. But what is electric force? How do we get electric force, sir? Electric force formula is, yes, electric force formula is electric field into charge. So tan theta is equal to electric force is electric field into charge. So they didn't okay, electric field tan theta is equal to electric force, which is eq by mg, and theta is equal to tan inverse eq. What is e, sir? E is the electric field due to large conducting sheet, which we discussed just now, sigma by epsilon naught. So sigma by epsilon naught into q by mg. So which option, sir? I think first one, no, sigma into epsilon naught mg. Okay, first option is the answer, sir. Very good. We'll go to next question, which is you can skip a little ahead, sir. Let's see. Here it is given. First, let us understand a thin spherical shell of radius r is there. Okay, thin spherical shell. Surface charge density on this shell is sigma. Now it is placed in a cube. It is placed in a cube which is having a side length of 5r. Okay. Now center of this spherical shell and cube are coinciding. That means exactly the shell is at the midpoint of the cube, sir, center of the cube. Now electric flux through one face of the cube they are asking. So what is the flux formula? Basically flux formula is sigma q by epsilon naught. So but here charge is not given. They told us surface charge density is present on this sphere inside. So q can be written as surface charge density into its area, sir. Okay, now what is sigma formula, sir? Surface charge density is charge by area. So charge is equal to sigma into area. So what is the area of 4 pi capital R square? Surface area of a charge is surface area of a sphere is 4 pi R square. So sigma into 4 pi R square by epsilon naught. So this is the flux which is passing through the entire cube. Okay, now how many faces are there for a cube? 6, sir. That means this total flux is distributed equally through 6 faces. So one face will get each phase will have a 1/6 of the flux we found out here, no? So simply if you substitute that formula, it will become sigma 4 pi r square by 6 epsilon naught. So if you solve it further, it will become 2 pi r square sigma by 3 epsilon naught. So which is the first option. Is that okay, sir? We'll go to next question. They told 36, first we will see 36. They told two concentric conducting spheres are there. The outer sphere is hollow, inner sphere is solid, sir. Okay, outer sphere is hollow, like this. Outer sphere is hollow, inner sphere is solid. Now they have given a charge of they have given a charge of minus 7q on the outer sphere plus 2q on inner sphere, sir. Okay, both are conducting sphere, so entire plus 2q will stay on the surface of inner sphere, minus 7q will be on the outer surface of outer sphere, sir. Okay, now because of this plus 2q, there will be a charge induction of minus 2q on the inner surface of conducting sphere. Okay, now because minus 2q came here, the remaining charge of minus 5q will be staying on the outer surface of the sphere. Now the question is, uh, what are the charges on inner sphere and outer sphere of outer sphere? Inner surface and outer surface of outer sphere. So minus 2q minus 5q. So which option? Third option, sir. Is that okay? Now see, sir, 37th they have given a simple pendulum of mass 40 grams. 40 grams mass is there, and positive charge of this ball is given a charge which is 4 into 10 power 6 coulomb, oscillating with a time period t1. Okay, you know what is the time period t1 of a simple pendulum which is hanging because of, like, it is executing shm because of gravity, 2 pi root l by g, sir. Okay, now electric field intensity is applied vertically upwards. Now the time period is t2. See, its weight is acting downward, electric field is acting upward. That means time period formula we have discussed in the class. What is the time period formula? Length will be same, g effective will be g minus due to effective acceleration, like g effective will be eq minus g minus eq by m. Okay, this is the acceleration. This is a, like, we got this formula by calculating net force on the simple pendulum bob, sir. Okay, now they are asking ratio of t2 by t1. What is t2? T2 is equal to, like, everything gets cancelled, only remaining thing is root of g minus eq by m. So t2 by t1 will be root g by g minus eq by m. Okay, now g value is 10, sir. We will take 10, and 10 minus e. What is the e value? Electric field 3.6 into 10 power 4. Charge, how much charge is there? 4 into 10 power minus 6 by m. What is the mass? 40 grams. 40 grams means 10 power minus 3 kilograms, no? So you have to solve this value, then it will become under root 10 by 10 minus let's solve it, sir. So this 4 gets cancelled. This 4 gets cancelled, and 10 into 10 power minus 3. So in the denominator 10 power minus 2 is there. 10 power minus 2 will get cancelled in 10 power minus 6, 10 power minus 4. 10 power minus 4, 10 power 4 gets cancelled, will give you 1, sir. So this is 3.6. 10 minus 3.6 means 6.4. So 10 by 6.4. They are asking ratio for t2 by t1. So under root 10 by 6.4, which is we'll do one thing. Like, we'll go roughly, sir. Why? Because of the options are far away from each other. So this can be written as okay, it can directly cancel. Root 100 is 10, and root 64 is 8, and 10 by 8 means point 2 1 8. 2 gets cancelled. 1 point, if you put 1 point, you can keep a 0. So 2 8 is 16, again 4 point with 0, so 5 4, so 1.25, so answer is 1.25. Is that okay, sir? Third option. Okay, now see, sir, 35th question. What is 35th question? A uniform charged ring R electric field on its axis has the largest magnitude at a distance h from its center. I'll explain the question, sir. 36, sir. So they're telling there is a ring of a radius capital R, and there is a point at a distance of h. Now this ring is having a positive charge around it, sir. Okay, now because of that electric field is created, no, we know. So at which point, at what distance the electric field will become maximum? For that we need to have first electric field, which is kqh by r square plus h square whole power 3 by 2, sir. Okay, now we have to, they are telling at what distance of h e becomes maximum. So this is the problem of minimum and maximum. So if a function has to be maximum, its derivative should be 0, no? So what is the variable here is h. So we will derive this with h. So it will become, so first let's derive, sir. What is this? It should be 0, sir. So if you do derivative, h into its derivative is 3 by 2 r square plus h square whole power 3 by 2 into h square derivative is 2h minus r square plus h square whole power 3 by 2 into derivative of h is 1 only, divided by something is equal to 0, no? So that something anyhow becomes 0. What is something? Nothing, sir. H square plus h square, r square plus h square whole power 3 by 2 into whole square. Usually derivative formula is, so it will proceed forward in this way, so de by dh should be 0. So this function should be 0, which is let us take r square plus h square whole power 3 by 2 common, sir. Then it will become h 2 also gets cancelled, and h square 3h square r square, sorry, this is 1 by 2, no? So 1 by 2 if you take common, then nothing left here, sir, just 3h square. Then in this term we have taken r square plus h square whole power 1 by 2 as common, then remaining is r square plus h square is equal to 0. So 3h square minus h square plus r square is equal to 0. So 2h square plus r square is equal to 0. Then h is equal to r by root 2, sir. So what is the distance from the center of the ring? That is r by root 2. So this distance should be r by root 2 to get maximum electric field. That means before that electric field will be less, after that electric field will be less. Exactly at this point electric field becomes a maximum. Okay, sir. Like a graph follows like this. Sometimes they'll ask graph also. So you're starting from origin electric field peaks at some certain point, which is r by root 2, then again electric field reduces. Okay, now so in which shape of the what is the shape of the curve? It takes 1 by r square 1 by r cube graph, sir. Okay, thank you. We'll go to next question. Next question would be here we will see, sir, what is given. Now cylinder is given. 39th I'm doing. A cylinder is given, sir. We're having a flux passing through this curved surface is phi. Charge is kept at exactly at the middle, and the flux which is passing through left surface is phi 1, right surface is phi 2. Now they are asking what is the flux through circular surface, circular phase. That means total flux will be 2 phi 1, actually phi 1 plus phi 2, which will be equal, no? So 2 5 I am taking, so remaining flux is flux passing through curved surface, that is equal to total q by epsilon naught. So what is the flux passing through phase? 2 phi is equal to q by epsilon naught minus phi, and phi 1 is equal to 1 by 2 of q by epsilon naught minus phi. So which option? First option, sir. Okay, next. So let's do 47nd question, sir. Two point charges plus 2 micro and plus 8 micro are placed at 15 centimeters apart. Q1, Q2 both are placed 15 centimeters apart. Charges are also given, and at a point on the line joining these two charges, net electric field is 0. A third charge of plus 5 coulomb is placed. Wherever electric field is 0, at that point a third charge Q3 is placed and its value is also given. Net electric force acting on plus 5 microcoulomb is simple, sir. If Q3 is placed at the null point, we already learned how to, what is the formula of null point? What is the formula of null point, sir? X is equal to d by 1 plus root q2 by q1. I told if the charges are same, then formula will take plus in the denominator, and x is calculated from q1, sir. That means we are calculating x here. So what is the answer? What is the d? 15 centimeters, which is 10 power minus 2 meters divided by 1 plus root q2. What is q2? Q2 value is here it is given 8 microcoulomb. Q1 is 2 microcoulomb, so gets cancelled. Micro gets cancelled, and answer is 8 by 2 4. Root 4 is 2, so answer is 15 by 3 10 power minus 2 meters, and its value is 5 into 10 power minus 2 meters, sir. Okay, now they are asking what is the electric force on 5 microcoulomb which is kept here. So force created by F2, second charge will be F2, force created by first charge is F1. Net force is F1 minus F2, magnitude of F1 minus F2, which is F1 is K Q2 Q3, F1 is Q1 Q3, sir, by x square minus F2 is force created by second charge, that is K Q2 Q3 by x value is 5, total distance is 15, so remaining distance will be how much, sir? This is let us take 15 minus x whole square, sir. Okay, now I am taking K Q3 by KQ3 I will take common, then it will be Q1 by X1, 5 into 10 power minus 2 whole square minus Q2 by distance 5 minus X, 15 centimeters minus 5 centimeters, 10 centimeters, sir. So 10 centimeters means 10 power minus 1 meters. 10 power minus 1 whole square will be 10 power minus 2. That value will substitute. What is the K value? 9 into 10 power 9. Q3 value is 5 microcoulomb, that is 5 into 10 power minus 6. What is Q1? Q1 is 2 microcoulomb, 2 into 10 power minus 6 by this 25 10 power minus 4 minus Q2 8 microcoulomb, 8 minus 6 by 10 power minus 1 10 power minus 1 whole square, 10 power minus 2. So answer will be, you calculate, you will get this answer. Let's do one thing, 9 into 5 45, 10 power 9 into 10 power minus 6, 10 power 3, and this will be 10 power 2 by 25, 10 power minus 2 my 8 10 power minus 4, and somewhere we have a mistake. So this is a method you will get the answer, sir. I think I have went wrong somewhere. Okay, we'll see in the next question.